Okay, let's continue from where we left off. Pre-calculus fundamentals. So there are various aspects of pre-calculus that we continue to look at. So here we look at the radicals. Remember, we just looked at the exponents. So these two are quite interlinked. So we can define radicals as perhaps simply as the opposite of exponents. Why opposites is because exponents normally deal with integers, the radicals are fractions. Okay, it's like integers flipped. So then you get the radicals, and these are represented by the radical sign, which is that symbol there. So for example, root of a is equal to b, means that that's the square root. The radical sign for square root is the same as a power half, and so that can be simplified into, for example, a is equal to b squared in that format there. Okay, so when it comes to mathematics, obviously we have to be able to see the patterns. So we're trying to see the patterns here. Root 16 is same as 16 power half. Then we can neutralize the half there, and by multiplying by power 2 on both sides, and then we get 16 is equal to 4 squared. Same can happen with root 81. We get half radical, half power there, neutralize it, and then we get 81 is equal to 9 squared. These are simple basics. Remember, if you see a radical sign, it doesn't have a number in front, then it means that it's a square root. Okay, it means that it's power half. Okay, number power half. And so now we don't limit radicals to root of 2, and so or square root. So generally these are represented as nth root, meaning that when n is 2, you have a square root. When it's 3, you have the third root, 4, fourth root, and so on and so forth. So this we say is the nth root. Okay, so nth root of a, we can represent this as a is equal to b power n, obviously using the same simplification method that I showed earlier. Okay, so this is how you simplify. You've got to be able to see that fraction there. Okay, so for example, for fourth root of 81, again we just put the fraction there, okay, of 1/4. We can balance this out by multiplying by the same power on both sides, applying the same power on both sides. Then we have 81 is equal to 3 power 4. Okay, so these are just simple basics, just trying to see if we can remember before we go into advanced mathematics. Okay, then here we have properties of radicals. Again, these help you to see the patterns. So nth root of AB, okay, we're multiplying A and B, is the same as nth root of A and nth root of B. Okay, very important. The dot in mathematics normally means multiplication if it's not in between numbers. Okay, then nth root of A over B, this one gives us nth root of A and then nth root of B. Okay, that's another pattern to recognize. When we see these, we know what's going on. Okay, so that's the second property. Then we go to the third property. The third property is nth root of A. So again, we have to recognize and remember our fractions. So a 1 over n, and then we have 1 over m as powers there. Okay, so we can multiply those two using the properties we learned earlier in another video. And those two come together like that. So you have mnth root of a. Then if we have a, then a, n like that, you can simplify that and you see it becomes a. So that fraction, be able to recognize that power as a fraction is very important. So a when n is odd, it's a when n is odd, and then it's you get the absolute value of a when a is even. Okay, so it's not always to say that it's a. Okay, then let's practice with a few examples here. Okay, so now let's simplify these two examples. Okay, so we have 3x power 4. Okay, that's the third root of x power 4, fourth root of 81, x8, y4. Okay, so let's start with 1. What are we going to do to simplify this? We have to recognize the patterns. How can we split x4 that we can apply the third root? Okay, so we have to remember the addition of exponents. So we can split that. What happens? Where do the addition comes from? It comes from multiplying identical bases. So we have x1, x3, x1, 1 over 3 there. Then we expand into the brackets using the properties we learned, and then we have that. Then we can put the radical sign back, but then we have simplified the contents of the radical sign. Okay, so that's simplification. Let's look at number 2. Okay, you can pause these videos and practice on your own. Okay, so we have 81 x 8 y 4. Okay, now here again we have to recognize the different expressions that the whole expression has, and also the exponent that we're using. Okay, so we split the number from the rest of the expression, x8, y4, we split them like that. We see those patterns, and then we apply the fourth root on 81. We apply the fourth root on on x8, and then we apply the fourth root also on y4. Okay, so we can expand 81 into 3, 4, and then maintain the fourth root. We can already simplify that one into x2, and then we simplify y4 as well. Okay, so once we simplify these, we get 3x2 y4, or y, but then y, remember, we've used an even number there, so it's going to be an absolute value. Okay, x. Okay, now let's look at the one property that we can include. Okay, so let's say a plus b is not equal to root a plus root b. This is something that we need to take note of. And then this comes back. We looked at this as well. Let's remember that these two are not equivalent, they're not equal. Okay, these are some of the things that students usually make mistakes on. Okay, so we have to be very sure that of what works and what is not part of these laws. Okay, then let's look at rationalizing the denominator. This is another important concept that you'll find when dealing with advanced calculus. So here you've got to be able to understand how we are going to rationalize the denominator. When you do limits and all those kind of things, you still need that. So we multiply by 1, and 1 is root a over root a. Remember, we're not going to simplify here. We're going to use the concept that we used on exponents. So this is a power half, we add the halves, and then we get 1 to give us a. Okay, so this is how we added. Half plus half gives us a whole, which is 1, and then that's a. Okay, right. Okay, now there's another property that is also crucial when n am is multiplied against n minus m. This is supposed to give us a. Okay, how? Let's look at how we proceed here. Again, you've got to be able to understand the nth root in exponent form. We change it to that, and then also here the nth root, we change it to that. Then we can factorize the common exponent. Okay, and then we have that remaining. Then we can use the product rule where we add exponents. We're going to add them like that. We can cancel out the m's. We have a power n, and then outside we have 1 over n. Those can cancel out, then we have a. So we need, sometimes you can be given to prove that expression gives you a. Okay, and that's how you actually do it. Okay, we'll see a lot of these concepts as we go. All right, let's go and look at final radical that we can try to simplify. Okay, this is crucial when it comes to limits. If you don't understand radicals and how to rationalize them, you can't do limits. Okay, so here we have 2 over 3, root of 3. Then we have that, again, we multiply by 1, and remember how we got 3 there. Okay, so this concept, again, I cannot emphasize it enough. It's crucial. Okay, it's crucial. All right, thank you so much for following, and all the best.